Waste incineration, chronic poisoning on the people. Part 9. C. The influence of waste incineration plant combustion and gas cleaning technology on dioxin emissions. Diplom-Ingenieur G. Bröker from the VDI in Essen, Germany, examined the problem. What must be done to reduce the emission of chlorinated dioxins and furans from world incineration plants to a minimum? He came to the following conclusion. In waste incineration plants, the chemical and physical composition of the fuel changes constantly during combustion. Time and location dependent, this leads to zones of oxygen deficiency and lower temperature, which in turn lead to incomplete combustion, with the consequence of the formation of carbon monoxide, hydrocarbons and soot. There is clear evidence that the emissions of dioxins and furans is dependent on the input of chlorine compounds, but there is no realistic chance of reducing the amount of harmful substances in the waste so as to reduce dioxins. So-called favorable combustion conditions like high temperature, adequate resistance time at high temperatures, high turbulence through improved furnace geometry, and sufficient surplus oxygen have not led to a permanent or significant reduction of dioxins or furans. The admixture of sulfuron additives which can reduce the chlorination reaction must be tested further. Instead of subscribing with water to clean the gas, as the past, preference should be given to a dry process or semi-dry process. In the semi-dry process, the flue gas are fed directly into a reactor at between 255 and 270 degrees Celsius. Using injected lime slurry, the gases are then cooled to between 110 to 140 degrees Celsius and are cleaned. The dosage of lime slurry is regulated according to the composition of the flue gas, so that the liquid evaporates completely and the suspended hydrate of lime is dispersed in the flue gas as fine particles, which are then separated by fabric filter. Canadian authors have measured separation levels for over 99%. Perhaps this is the more than 99% which the doctors Eikmann took up and quoted. Diplom-Ingenieur G. Bröker was more cautious. One way to reduce dioxins in the flue gas possibly is semi-dry or dry flue gas cleaning, if the Canadian measurements can be verified on a flue gas cleaning system of this kind. At present, we are not aware of any conclusive universal construction principles which can be applied for the firing process for preventing the formation of dioxins or furans during the incineration of waste. This means that the formation of dioxins and furans depends basically on the material. It can scarcely be avoided from furnace-related measures. The promote of the waste incineration plant as a pollutant sink must really almost exclusively in the effectiveness of flue gas cleaning, and that in the phase to 10 high 26 to 10 high 28 flue gas products per second. There are, however, reports of finding which suggest that the recently introduced semi-dry process, the effluent-free spray absorption by means of lime slurry injected into the flue gas, possibly with the addition of heat furnace coke, attains high removal efficiencies of exit, oxides of nitrogen and sulfur, carbon dioxide, organic compounds and dioxins furans. But compared with earlier multi-stage gas cleaning plants, which need between 5.5 and 6% electricity, the semi-dry process is regarded as a simplified gas cleaning system which needs only between 2.5 or 4% electricity. The multi-material mixture weld incineration plant flue gas raises many more questions about displacement processes in the lime particulates from cleaning, about where the finest and ultrafine dust from waste incineration plants goes, and so forth. But let us return to what we called above the most important thing. It is especially important that we do not allow ourselves to be distracted by the regulation in 17th BImSchV and its promoters from the fact that the dioxins and furans appear mainly in the slag, in the fly ash and in the dust washed off the filters, in the places where the highest proportion of soot is found. During loading and transportation of these large amount of solids from waste incineration plants, the highest so-called diffuse emissions are released into the atmosphere. They impact the immediate area around the waste incineration plant and are carried by wind and weather even further away. Strictly speaking, every waste incineration plant, contravenous the new German Soil Conservation Act, which came into effect on March 1st, 1999. Its aim is not only to deal with dangerous waste sites from the past. With this law to protect the soil, dangerous changes in the soil also are to be avoided prophylactically. D. The relevance for the environment and toxicity. The relevance of dioxins lies, on the one hand, in their high biological and chemical stability, and on the other hand, in their toxicity, which varies greatly for each isomer and is apparently type-specific as well. Their high biological and chemical stability and their long persistence in the aerobic environment lead unavoidable to accumulation in these poisons, including heavy metals, not only over short distances, but also far away. Warning examples are many Scandinavian inland lakes from which all plant and animal life has disappeared because of the lakes have been acidified by air pollution from industrial areas in the British Isles. Researchers from Switzerland and others at the VDI conference explained why the halogenated dioxins and furans, substituted very systematically in the 2, 3, 7, 8 positions, are the most poisonous for humans and why they are the most difficult to break down, which is the way they accumulate in humans. When absorbed, researchers estimate the poisons remain in human fat and fat-like lipid structures in the nervous system with a half-life of 6 years. Lipophilic substances like DDT, hexachlorobenzene, HCB, polychlorated biphenyls, PCBs, the sevesodioxin, and other pluriclinated dibenzopidioxins, PCDDs, can be concentrated by several powers of 10 in aquatic organisms, fish, and can be possibly cause toxic effects. Especially the PCDDs and PCDFs with the highest toxicity, the dirty dozen, which are substituted in the position 2, 3, 7, 8, accumulate. they have the greatest potential for bioconcentration. The higher chlorinated up to 8 substituted PCDDs, PCDFs have a spatially more bulky molecular cross-section. Because of that, the permeation through membranes is greatly reduced. They can only reach the target organs with great difficulty. Even as early in the 1986-87, chemists said that the concentration in plants is naturally considerably lower because of their small fat lipid content. For this reason, it is unfair of the doctors Eikmann to cite, of all things, their low accumulation in plants as proof of the harmlessness of waste incineration plant flue gases. Animals' fat, that means milk and meat, is the source for the concentration of dioxins and furans in humans. Even in humans, these lipophilic substances are accumulated and remain for a long period of time, especially in fat, possibly in the breast milk, in the lipid structure of the skin, the nervous system, and of the immune system. Even after 6 years, only half of them are excreted. In future, everything should be done to avoid the formation of PCDDs and PCDFs and of their fluorinated or brominated analogues, so that the concentration in the environment will not increase, more to make the chronic dangers become acute dangers for humans and environment. This is the unanimous opinion of engineers and chemists who worked on that issue at VDI conference. According of the hazardous properties classification regulation of the German Chemical Act, they are all dangerous to the environment. They all get into the environment through waste incineration plants, if not so much through flue gas, then more through solid matter, slag, ash and dust.